All right, so today we're doing 5.3, which is the third and final way that we can solve a system of equations. So we've learned graphing, solving by graphing. We are visually looking for where the 2 points cross each other. And then we learned solving by substitution, where we got one of the variables by itself and substituted what it was equal to into the other equation. And our third one is going to be by elimination. So we're going to be eliminating one of the variables so that we can solve for the other variable. So review of vocab, coefficient is the number in front of your variable. So if I have 2x, then my coefficient is 2. If I have a negative 4y, then that means negative 4 is my coefficient. Okay, so how do we solve a system of equations by elimination? You're going to multiply, if necessary, one or both of the equations by a number so that at least one pair of terms has the same or opposite coefficients. So step one, we may not always have to do. The first couple examples we do, we won't be using step one, but sometimes we will need step one. Step two is to add or subtract the equations to eliminate one of the variables. Step three then is to solve the resulting equation. And then step four is to substitute back in, because if we find x, we also have to find y. Okay, so let's take a look. All right, so if I take a look at number one, if I put a plus sign right here and draw a line underneath, when I add my columns, so x plus negative x cancels out, 3x plus 2y is 5y, and 17 plus 8 is 25. By adding each of my columns, by adding those like terms, my x's, my y's, and my constants, I was able to get my x's to completely cancel out. And once I have just one variable, I'm able to solve that equation. So it's 5y, so if I divide by 5, then I get what y is. And there's half my answer. It eliminated x, so I could solve for y. And now I just need to plug back into one of the equations so that I can solve for x. So I'll use the first one. So x plus 3 times my y, which was 5, equals 17. So I have x plus 15 is equal to 17. And then if I subtract the 15 from both sides, then I get x is 2. So my answer would be 2, 5. Remember, we're still looking for the coordinate point where the two lines intersect. So instead of finding it visually now, we're finding it using elimination. So go ahead and try number 2. Okay. So number 2, if I add my columns, 2x plus 5x is 7x, negative y plus y cancels out, and 16 plus 5 is 21. One step to solve it for x from there. If I divide both sides by 7, I get x equals 3. If I have x, all I have to do is substitute back in to solve for y. So I'll use the second equation on this one. So I have 5 times x, which is 3, plus y equals 16. So 5 times 3 is 15. If I subtract the 15 on both sides, then I get y is 1. So my answer would be 3, 1. Okay, on number 3 though, it's a little, 3 is the same. If I add my columns, my x's are going to cancel out. So my x's cancel out. 3y plus a negative y is 2y, and 10 plus negative 2 is 8. If I divide both sides by 2, then I get y is 4. Again, I'm not done until I have both an x and a y. So I've plugged in for y, and now I can solve for my x. So I'll use the top equation. So 2x plus 3 times my y, which is 4, equals 10. So 3 times 4 is 12. If I subtract the 12 over, then I get 2x is equal to negative 2. And when I divide by 2, I get x is equal to negative 1. So I get negative 1, 4 for my answer. Okay, so now that we're getting to number 10, number 10 is then going to be a little different because if I add my columns, none of my variables cancel out. However, if I choose to multiply the second equation by negative 2, so everything gets multiplied by negative 2. Let's see what happens. This gives me a negative 4x minus 2y, and then that would be minus 38. I'm going to just rewrite the top equation right above it. So x plus 2y equals 20. So why was multiplying by negative 2 helpful? Well, because now if you take a look at my y's, they're going to cancel out. So how did I decide to multiply by -2? Well, I looked at my y's and I thought, what would I need this y to be to cancel out? So 2y and a -2y would cancel out, so that's why I chose to multiply by a -2. I could have looked at what would cancel my x's out, and if I actually multiplied the top equation by -2, then my x's would have canceled out. So it doesn't matter which variable you get to cancel out. And once you've done that, it's exactly the same as the other ones. So x and a -4x is -3x, 2y and a -2y cancels out, and 20 and 38 is 18. Divide by my -3, and I get x as -6. Again, I'm not done until I have both an x and a y, so I need to plug back in. And I can actually plug into the original equation here, or I can plug it into the one I created. It does not make any difference which one I plug it back into. So I'll just plug it into the bottom equation before I multiplied by it. So 2 times -6 plus y equals 19. 2 times -6 is -12. When I add a 12 to both sides, I get y is equal to, what, 31. Okay, so I get -6 comma 31. I can write it like that. I can write it as a coordinate point. Either way is okay. Okay, so on number 11, if you take a look at it, there's nothing I can multiply one equation by to get them to cancel out. However, I actually am going to have to multiply both equations by something on this one. So, so on number 11, if I want my x's to cancel out, let's see what I would have to do. So if I multiply this equation by a -4 and this equation by a 3, I'll actually get a -12 and a 12x, so they will cancel out. So when I do that, I get a -12x plus 8y is equal to 8. And then I get a positive 12x minus 9y is equal to a -12. When I add my columns, my x's cancel out, and I'm left with a -1y is equal to -4. If I divide both sides by -1, then I get y as a positive 4. And then I plug it back into one of my equations. It doesn't matter which one I do. I'll just choose the top one. So 3x minus 2 times my y, which is 4, equals -2. Okay, so I have 3x minus 8 equals -2. If I add the 8 to both sides, then I will get 3x equals 6, which when I divide by 3 gives me x equals 2. So again, I have a coordinate point for an answer, 2, 4. All right, as always, if any of these you have questions on, mark it and ask me about it tomorrow. Okay, the last one, there's just one thing I need to do for multiplication. If I multiply this equation by a -3, then one will be a 9x, the other one will be a -9x. Again, I want them to have the same number in front, the same coefficient, but opposite signs. So I'll keep my top equation the same, 9x plus 4y equals 11. My bottom equation will become a -9x, and then plus 30y, and then equals to 6. So my x's cancel out. I get a 34y is equal to 17. When I divide by 34, I get y is 1/2. It's okay to get fractions or decimals as answers. And then I would just need to plug that back in. So I'll just choose the top one. So I have 9x plus 4 times 1/2 equals 11. So I substituted in for my y right there. So I have 9x plus 2 is equal to 11. When I subtract a 2 on both sides, I get 9x is equal to 9. And when I divide by 9, I get x equals 1. So my answer would be 1, 1/2. All right. Last one's a word problem. We're doing it the same way. We're going to set up two different equations because there's two variables that we are trying to solve for. If you need two variables solved for, you need two equations to help you solve it. So go ahead and try number 19 when you think you've got it. Unpause the video and come back and check it. Okay, so it says the two numbers is 22. So if I call the two numbers x and y, then when I add them, I get 22. The difference of those same two numbers is 6. Difference means subtraction. So if I subtract my two numbers, I get 6. And then it says, what are the two numbers? Okay, so this is set up great for elimination. If I write them one below the other, my y's actually cancel out. So I get 2x is equal to 28. When I divide by 2, I get x is equal to 14. If I plug that back into one of my equations, I have 14 minus y is equal to 6. If I subtract my 14 over, I get negative y is equal to negative 8, which when I divide by negative 1 means y is equal to positive 8. So what are my two numbers? My two numbers are 14 and 8. Okay, take a second, write your summary, and then mark any that you have questions on. Come to class prepared to ask any questions. Remember, as you're doing your notes, all of these examples should be in your notes, not just the vocab, not just the steps. Everything we've done in the notes should be in your notes. Okay, see you tomorrow in class.